With the type rules we've just defined, this expression has a type. It's a function call where the function takes a record R with type x:(num), means a record with a field x that has type num. The argument to this function is a record expression, and that expression has type x:(num) as a record expression, as a record type. And so based on our rule for function calls, we've got a record type here and a record type here, and they match up, so everything's great. But our type system so far actually rejects some other programs that we would like to work. Here's another example where we have a function that takes a record with x and y fields and it just gets the x field out. The argument is a record with y and x fields. So based on our type rule so far, this expression doesn't have a type because this type here is not exactly this type here. The x and the y fields are in different orders. So we would like to adjust our type rules to allow this kind of thing to work because none of the operations on records are sensitive to the order of the fields within the record. There's an even bigger problem. Here's an example where we have again our function that takes a record that has an x field, and now we are applying it to a record that has an x and a y field. So once again, this expression has no type currently because this record that we pass in has extra fields relative to what the function wanted. And adding extra fields should always be okay because again, we don't have operations that depend on the absence of fields. As long as there is an x field in the record, then this function is going to be happy. So what we want, especially for that latter case, is the notion of a subtype. The type tau is a subtype of tau prime, or when we write it, and we write it like this, tau less than or equal to tau prime, but we read this as tau is a subtype of tau prime. Whenever we have an expression of type tau, if we can use it where an expression of type tau prime is expected, then we say that tau is a subtype of tau prime. And so we want to say that a record with x and y fields is a subtype of a record with x fields. So this type for records no longer means a record with exactly an x field. It means a record with at least an x field, where the x field has to have type number. And if you have a record that has at least x and y fields, then it's a record with at least an x field. And so we say that this type, record with x and y, both num, is a subtype of record with type num. And this works for, we can use this to allow the order to change. We can say that a record with y and x fields is a subtype of x and y fields. And we can also say that a record with field x is a subtype of that same type, right? A record with x of type num. On the other hand, if we have just a record where all we know is it has a field x, we cannot use that where we need a record that has at least x and y fields. Right? And so the intuition behind this notion of subtyping is that if you have an instance of a subtype that's more rare than the kind of type it can replace, right? Lots of fields have at least an x, and some subset of them have both x and y in them. And that is why we use the less than. It's a kind of subset operation if you use that intuition. The way we write it down is in this mathish notation. We say that this type is a subtype of this other one if all of the fields in this type on the left, if there are more of them, if it's a superset of the type over here. Right? So this is saying you make a subtype by adding more fields. And then for the fields that do match up, wherever xi and x prime j are the same, that the types also need to match up. Right? So if we have an x over here and an x over here, then they both need to have type num. To finish defining this subset function, we need to make it work on all types, and so we just say num is a subtype of num, bool is a subtype of bool, and every function type is a subtype of itself as well. And with that, we can adjust our application rule to say that you need a function that takes a t1 to a tau3, and you need an expression. We used to write tau1 here. Now I'll write tau2, and I'll say that tau2 has to be a subtype of tau1. And by defining subtype just on all types, we don't have to specialize this rule somehow to record types. We can just use subtype to say when things are allowed. So with that in place, now we have our function that wants a record with an x field. We're supplying a record that has X and Y fields. It's an extra Y field, and that's okay because this record type with X and Y fields is a subtype of the record type with X fields. Similarly, if we reverse the fields, the field order, if the function wanted a Y and an X and we give it an X and Y, that's okay because X and Y is a subtype of Y and X. In this example, we have a function that wants a record that has an X and a Y field, and it's going to use the X field. I'm providing it a record with just a Y field. So this is not going to work when we run it. There is no X field inside here. Does the type system allow it? No, it does not, because this record type with just a Y field is not a subtype of one with X and Y fields. In other words, every record that has at least a Y is not necessarily a record that it has at least an X and a Y. So our type system properly rejects this expression, and we won't get the field not found runtime error.